We'll do geophysical and geotechnical surveys to allow you to get a really accurate interpretation of the site, making maps of the seabed to highlight where all of the bad places are to put the turbines, and then we avoid those and put them in the nice places.
Welcome to Beyond Energy, an Ocean Winds original series. An in-depth look at how offshore wind projects become reality and why their impact extends far beyond the offshore wind farms. Beyond Energy explores the full journey, the decisions made, the challenges overcome, and the people and places shaping each step. This is Beyond Energy.
My role day-to-day as a geophysicist is essentially looking at geophysical data. So that can be anything from multi-beam echo sounder, side-scan sonar, magnetometer, sub-bottom profiler, and UHR data, which we use to map the seabed and subseabed features to advise clients on the best location to place their infrastructure.
We start with the reconnaissance geophysical survey. It's a few months, 3-4 months on site, and that covers the full site, high resolution. We then do a reconnaissance geotechnical survey. So we've studied the geophysical data and then decided where are the various soil types from that interpretation. And then we go into the detailed geotechnical surveys. So that's every foundation type down to the foundation installation depth. That will then be used for the detailed design and kind of define the layout for the wind farm.
Before anything is built offshore, we scan the seabed to uncover risks and plan the safest foundations. From sonar to soil tests, every survey reduces risk and guides how and where we build offshore wind.
We'll take all the geotechnical and geophysical information you acquire, you integrate them into one concise ground model, and then you'll design a complete concept based on what you find.
Survey data guides how and where we build. Soil that's too soft or too hard can fail. A pile that sinks too far or won't go in at all, we avoid that by knowing the ground before we build. Survey data helps us match the right foundation to the right location. Monopile or jacket. That depends on what's below. With sonar and boreholes, we build on what's solid. We use geotechnical and geophysical data to inform our design and installation methods so we can build safely and with confidence.
The more detail you have, the better picture of the seabed you've got. Now, the seabed can be a touch mobile, and you need to monitor that and keep a close eye on it to make sure that your infrastructure is going to be safe. Whether that's floating or fixed platforms, you need to look at the specific seabed landing locations, making sure that the seabed is stable enough. You need to avoid the potential UXOs in the area, but also if you're drilling down into the seabed, you've got to look out for other potential subseabed hazards such as shallow gas, like soil creep and shallow problems like that.
It's a continuous life cycle the whole way through. For the operations and maintenance phase, we do a yearly balance of plant surveys. So we go out and inspect the cables, looking at the cable burials to make sure they are still buried to the required depths. We also then go and inspect the jackets to make sure that there's no corrosion, excess marine growth buildup, any damage. It's analysing that data, comparing it to what we got through construction, and then making decisions on do we need to do any remedial work.
If you give 30 geophysicists in a room the same piece of data, you'll end up with 30 different interpretations. Over huge scales, like over a wind farm size scale, there will be small areas of uncertainty, and the key is understanding what's uncertain and what is certain.
From a technical point, we want all the data so that we can make an accurate interpretation of the site. Bearing in mind it is an interpretation. If you move 5 meters, 10 meters, 100 meters, 1,000 meters away, you're interpreting it from the geophysical data, and that isn't always right. That then leads to questions which don't have definite answers until you go back to site and get more data.
Ocean Winds have made huge leaps in the offshore wind game, really leading from the front, showing other operators how to operate sustainably and push forward, especially in quite challenging circumstances.
At Ocean Winds, I'm involved in the project from the start right the way through the end, building something that I think is achievable and realistic and actually really good for the world.